Okay, so the final video for this week will be talking about using Centroid method for locating single facilities. Now, single facilities are actually very important, and they come up in different scenarios. One obvious scenario is your Amazon, and you're trying to figure out where should your regional distribution center be based upon all the demand you have in a certain region. Other examples are, let's say that there are five villages somewhere in rural Nebraska who have decided that they want a public library between the five of them. So where should the library be located? Again, it will be based upon the populations and how many people read books in each of these villages and whatnot. But again, you're locating a single facility that has inbound and outbound people coming from different locations. So that's in these scenarios we use the centroid method. So the idea behind the centroid method is simple. So we will assume that everything is two-dimensional, even though the Earth is curved and you have latitudes and longitudes and whatnot. Technically should be curved, but we'll look at it as a two-dimensional plane just to make our calculations easier, right? So the methodology involves these formulas to calculate the centroid. So dix is the x coordinate of a particular location, vi is the volume from that location. So we calculate cx and cy, that gives us the x coordinate of the centroid and y coordinate of the y coordinate of the centroid, either way, right? So let's take this particular example here. It's simple. We'll make it simple to understand. So there are, forget about the fact that the centroid is here. So you have 1000 oaks, x coordinate is 25, y coordinate is 450. So these numbers could actually be in miles. These numbers could be some other measurement that you've come up with in maybe kilometers or something else. It doesn't matter. So you have used some distance metric to calculate these x and y coordinates. They could be other geographical metric. It doesn't have to be a particular distance metric. But either way, so Thousand Oaks is located at 25, 450. Glendale at 350, 400, La Habra at 450, 350, Anaheim at 400, 150, and Long Beach at 325, 75, right? And from each of these locations, we know that the amount of flow, the amount of gallons of gasoline that are required per month is 1500 to Long Beach, 250 to Anaheim, 450 to La Habra, 350 to Glendale, and 450 to Thousand Oaks. So given this, where should the central location be? So the central location will depend upon the x and the y coordinates, and also the number of units that you're transporting in and out, right? So what you do is you multiply the x coordinate with the volume, x coordinate with the volume, x coordinate with the volume, and you add them all up. Then you divide by the total volume that you have. That'll give you the x coordinate, and the same with the y coordinate, right? So it's very simple calculations, nothing too complicated. Yeah. And you find the centroid, and this is where you start the search for a new location. So the closer you are to the centroid, the closer you will be to minimizing the total cost, or total distance, or however you look at it, to the centroid location, right? Between all of these different things. And that's a simple way of locating these facilities. So what we'll do is, let's take this particular example. Let's put it into this into Excel. Centroid method. Right. Let me. That's not gonna work. Okay. Look at it this way. There you go. So we have our locations. Make the fonts bigger. Thousand Oaks. Right. Glendale. La Habra. Anaheim. And Long Beach. have the x coordinate and y coordinate. And you have the flow, right? So let's begin with 1000 looks. So this is 25, this is 450, right? Glendale is 350, 400. La Habra is 450, 350. Oops. Anaheim is 400, 150. Long Beach is 325, 75, right? Let's look at the flow. 1500, 250, 450, 350, and 450, right? So with this, we can find the centroid, right? The centroid here. How do I find the x coordinate for this? So we have to find the x coordinate for the centroid and y coordinate for the centroid. So you multiply 25 with the flow, 350 with the flow, 450 with the flow, and so on. So you multiply the corresponding x coordinate with the flow, x coordinate with the flow, x coordinate with the flow. You add that all up. That's the numerator. That's what you have in the numerator. Then denominator is just the sum of the flows, right? So that's exactly what I'm going to write here. So I'm going to say sum product of all the x coordinate values, comma, the flow values, multiply the corresponding values together, and then you divide this whole thing by the sum of all the flow values, right? Now, I want to write this formula for x coordinate, and then I want to copy it over to the y coordinate. So when I do it for the y coordinate, we'll be using the y coordinate values and multiplying them with the flow, but the flow remains the same. So for doing this, what I'm going to do is I'm going to change this into dollar signs with absolute references. The same goes for the denominator because the flow remains the same. That's the denominator. So this way I can find the centroid, the x coordinate of the centroid, and then I can find the y coordinate of the centroid. 307 and 216, they say. Huh. Because I'm missing something. 325. Ooh, I guess I messed up. All right, the flow values are different. I'm so sorry. Let me make sure I get the right flow values. Okay. Long Beach is 1500. Sorry about that. But because I wrote the formulas, everything will automatically get changed. Anaheim is 250. Okay. Then La Habra is 450 is right. Glendale is 350. And Thousand Oaks is 450. 307 and 260, right? So that's what they got. I'm just gonna make it so that I don't want any decimal places. Just gonna not show the decimal place, or maybe one. I guess that's what they have, right? 307.9 and 216.7. That's exactly what we have, and that's how you do the calculation. So it's, as you can see, it's a pretty simple calculation. It's very straightforward. Multiply the coordinates of the flow and you add them all up and divide by the total flow. The same goes here. It's basically a weighted average calculation, and that gives you the centroid, and this is where you should start looking for a good place to locate the warehouse, right? Okay, so I'm gonna end this video here, and this will be the last video for the week. All right, take care.